my name's Devin. I'm one of the founders of Devin, and I wanted to create this video today to talk about our debug scanning application we've been working on. So we've been building a source code analysis tool that basically takes source code and finds all of the security vulnerabilities and all of the bugs that exist within it. I'm really, really passionate about this because I work on a lot of software projects. My partner and I, we run an agency and we work on like mining CRMs and materials resource processing software. We've worked on a lot of really complicated software projects. And throughout my career, I have always been frustrated with the problem of software quality. There is this massive problem in software where the level of complexity just rises exponentially, and you very, very quickly in any software project reach this point of you don't really know what you don't know. Even when you work with a team, right, you break it up into domains and you give each developer a domain or each team a domain. But still, it's very, very, very rare that any of the developers in the team will have the entire piece of software for their domain in their head, and they'll be able to analyze it and basically understand it completely how it works. And that's because there's just so many branches through the logic. There's so many different runtime considerations and hardware considerations and everything that can go on to make software just something that you cannot deal with. And I think the biggest cause of this is that we analyze software on a file-by-file basis. I mean, I've been thinking about this for a very long time. I think the biggest problem is that when we look at source code, we are dealing with files. But code isn't run in files. Code isn't files. That's an abstraction that we use to deal with it. This has been something that's really bothered me for a very long time. And I've been very passionate about trying to understand this. And I'm very much one of those guys that really sits down with pen and paper and tries to work out how an algorithm works and tries to understand how they can break that complexity down and simplify it. But I've always run into the problem of course, to do this for an entire software project would require an army of analysts. You need huge amounts of people to do this. In fact, it would be more complicated to analyze the software in this level of detail than to actually write the software. Writing software is a lot easier than tearing it apart and analyzing all the different angles and everything that can go wrong. I'm really excited about this because with the advent of large language models, there's actually an opportunity to do something about this, to approach this problem in a very different way, because we can actually have an army of analysts. And I'm not trying to personify the large language model here. What I'm trying to talk about is the real assessment that large language models are very, very good at transforming one sort of data into another sort of data. And that has always been the problem with analyzing source code, is that the source code artifact is not a very good artifact for us to work with to understand software complexity. So my goal over the last couple of months has been transforming source code into artifacts and then taking those artifacts and compiling them into a high-level map of software with the goal of building an overarching viewpoint of the software with logic traces through all of the logic and all of the different paths mapped out. You can think of it as like Google Maps for your source code is what I tell my fiance. And basically this is a high-level map that lets you see all of the fracture points and all of the different considerations, and from any vantage point see every connection to that specific vantage point of the software. You're not looking at files, you're looking at the broader picture of all of the different complexity and all of the weaving, which is incredibly complex and has been an incredible challenge, and especially considering my own personal goal has been that the system has to work purely through code. It has to be, the code speaks for itself.
Just speaks for itself.
There can't be any comments, there can be no additional context, there can be no cheating. I did not want developers to have to come into our tool and set up rules and upload documentation and bring outside context, which is really different, I think, from what a lot of people are doing. I mean, you've got security scanners out there. And the reason that why LLMs have been able to gain a foothold in the security scanning space is because you've got technical complexity is really easy to separate. And technical complexity is more localized into files. You can apply more of a pattern matching approach. Versus what we're talking about doing is separating the business complexity from the technical complexity. You know, if you've got audit management, there is complexity in how an audit is conducted and the rules of when and how and who and what can do an audit. That is separate from the technical complexity, which is, Rust and lifelines and the specific details of, what database you're using. Those two things are completely separate. And understanding that business complexity requires a lot more analysis and a lot more of combing through and cutting up the files in 1,000 separate ways to pull out and verify what that is and prove what that is. But what this means is if we do that analysis, we no longer have to rely on the pattern matching of looking for stuff that's common core, common occurrence in a software project. And now we can look at what is the unique situation for this project. We can customize the analysis. We can customize the scan for specifically what trust is someone going to take advantage of to hack your system, or what are the most likely bugs that could actually cause problems for your users, and how do we double check that and verify that they're not in the software or verify that they are. And then how do we use the map to update over time using Bayesian analysis to hone in and not just waste time looking in places we don't need to look. So one of the cool things about that whole logic and that routing process is that, when you go and ask Claude Code, right, it's going to analyze the same way a human would. It's going to grep in, it reads file by file, and you get still this localized viewpoint, which is good for solving individual issues when you know what the issues are. It's very expensive for scanning through files. What we are able to do is actually hit and salt the earth, is what I like to say. Like, you're doing a big blast radius of, like, you are looking at everything everywhere all at once and then digging down and, very much honing in like a homing missile on where the actual fracture points are in the software and highlighting them. And I'm really excited to say that this is working really well. Currently, our system, you can basically index your code in 3 clicks. So you just upload your code, and basically it's going to automatically build this map where it identifies all of the different areas of functionality, and you don't have to do any documentation or rules. And these areas of functionality, as you'll see, are business areas. They're the business logic. It's not the technical logic of how your system works. It's actually the business of your software. And this is really important because you can salt the earth on a specific business area. I can narrow down into user management, session management, if I really want to make sure that the way I'm managing sessions is 100% correct. And then essentially the area scan will just take this viewpoint of looking at that area and looking at all the different fracture points and mining in and using this logic to come down the core. And if you really are salting the earth, it is a very large amount of processing that's going on. But because of the analysis and because of the structure we can do this in a very efficient way. The other type of scan we let you do is an issue scan. So an issue scan is a bit more, I like to think of it like sonar warfare, right? When you're finding a submarine, I like to read Tom Clancy books in case you, a bit of lore drop there. But in sonar warfare, right, you drop buoys to try and ping off the submarine and try and detect. And what we are basically doing is it's equivalent to a Yankee search, right, where we fire off a ton of different pings all across all the different areas to figure out if any of those areas could be related to your issue that you've uploaded that you want to get solved. And then basically it keeps zeroing in and tracing its way down through the map until it comes to the root and it finds your issue. But one of the cool things is that because you're tracing out this route through the map along the way, you're also surfacing all of these other defects along the path to the specific issue, to the specific root cause of your issue, which means that, say you ask Claude Code to solve a security issue, right? It'll come in, it'll fix the issue at the level of the file, but it won't see the further up the trace. It won't give you a full path of like, this is everything across, 20 different files, which still all follows this pattern. Because of the way we do the issue scans, you don't just get this singular solution to the issue, but all of the contributing factors upstream, any additional defects that are related, which merely allows you to take a bigger picture view on solving a bug. Because you're not just solving a bug, you're solving the broader context that caused the bug. And basically, we wrap this all up in a really nice package where essentially you can go through a list of defects, you can sort through them, you can sort by consequences, you can sort by severity, you can sort by a software area, so the business logic area in your software. And then basically you can resolve, you can dismiss them, you can assign them to users. We also let you generate AI patches, and we take a little bit of a different approach to this, where essentially, again, instead of just throwing it to the files, we're giving it the software map and allowing it to do a bit of querying around the map to identify the exact root cause of the software. And we give you this root cause analysis so that you can understand, okay, I've got this issue, but this is the cause of, in our design, that led to this issue actually being a problem. We also give you a unit test so that you can basically put that into your software to make sure that when you change your software, you've got an automated system to catch if something like this re-enters into the system. And then we also give the standard code snippets that you need to solve the problem. This software is all ready now. You can come in with your team. You can set up who can work on what repo. You can manage the context of who can do scans, who can do indexing, and who can see the dashboard. We have like a full dashboard, which gives you a bunch of stats so you can break down and see the big picture of how software defects are manifesting. I think it's a really useful tool for people to be able to come in and very quickly understand what the status of their software quality is. So I'm very passionate about this project. I'm really excited. And that's because I think for the first time ever, software quality is actually going to be a solvable issue, something where we can reach software which is at an incredibly high standard of quality, where it doesn't have bugs, it doesn't have security flaws, and it just runs really fast and really flawlessly. And I have a really interesting anecdote about this. So I have been using AI tools a lot to do coding. One, because they're a really good way to dog food the scanner. I get AI to generate a project for me, and then I basically use the scanner to pull it apart and find all the vulnerabilities and bugs in it. And typically I find quite a bit. I find maybe 50 to 70 issues for a small domain in a specific project. What is really, really interesting though, is that when I go through and I fix those bugs, I don't just get the result of fixing the bugs. And I should be clear, I'm using AI to help me fix these bugs here. But I don't just get the solution of like, okay, now it's bug free, great. What actually ends up happening is as you fix all of these issues, the code itself gets higher and higher quality, which I think is a really interesting effect of these models because they are predictive machines, right? When the context that is going in becomes this is a really high quality, really well thought out piece of code that's covered all of these different things and all of these different issues have been thought about, that starts to actually be fed in. So you get this feedback loop where you get this emergent property of the code that you get after solving all these issues isn't just bug free and doesn't have these security flaws. It's actually better, it's cleaner, it's faster, it does things in a more logical way, which is just really cool to see because I think it speaks to a really exciting future for our industry where we actually are able to produce code that is completely high quality and doesn't have breaking issues, that doesn't hurt customers, that doesn't have security flaws. And that's where I'm really seeing this going forward. And there's some big goals that I've got in the future. So going forward, I've got like 3 major things that we're looking forward to building. And I think we'll give this an even bigger leg up in what we're doing. So the first thing I want to do is I want to apply this map that we've developed, not just to bugs and security, but also to optimizations. So we can actually use it to find and identify the fracture points where the software could be faster or the software could be cheaper. Those 2 distinct goals, I think, sum up the basis of optimization. And I'm already using this in my own software, where I am very proud to say that the dev-in-a-box apps will respond to you in less than 50 milliseconds. And that's if you're in Europe talking to the United States server, it's really, really blazingly fast, faster than I expected it to be honest. And I'm also using this to make sure that stuff like storage and stuff for our app is cheaper and we're not running up as high a bill as we did. And I think I managed to cut my bill by 80% using the optimization tool alone. So I think this will be a big, big thing for people when it actually gets released. And I'm looking forward to producing more content showing off how that works and then finally releasing it to the public as a tool that they can use for everything that they're building. The other scan type that I want to build, and this is a bit more unusual and a bit more out there, and it might sound a bit esoteric, but stick with me. I want to make something called a stability scan. So you've got optimizations, you've got bugs, you've got security. Those are all focused on finding stuff in your code that's wrong. A stability scan is more trying to identify, take this big picture map and find the fracture points and create ways that we can analyze and add outside checks around those fracture points to make sure as we change the code or as we add new code, or if as we use the code, that we can understand that this is a stable system that's not going to break with changes. Because I think one of the biggest threats of for security is how does your system respond as you change the system? I think that's where most security vulnerabilities come in. I also think with AI tools, this is another major fracture point of like, hey, if we can't understand the quality of our designs and we're not directly working on our design, we're just working on the business logic and telling a language model to implement it as technical logic, how are we going to interact with this to make sure that we are building more and more stable, more and more high quality systems? And I think the answer to that is a stability scan. And you can think of this as a tool that helps you find good spaces for where a unit test would make your system a lot more stable, or property-based testing would be useful. But I also think there's a creative aspect to this. One of my favorite examples of software stability was from the team of Halo 3, Bungie Studios. And Halo 3 is like a first-person shooting game, which is online and people come into matches and they fight and shoot each other. But it's a networking game. It's a very much has to be optimized for the networking and the latency of when players come in and when they're shooting each other. And they had a massive problem when they started off of it was really, really hard for their developers to come in and understand the domain of the networking. They would come in and they would see sheet lists of latency scores, but it didn't really mean anything. And they didn't know if their optimizations were actually having an effect because they couldn't view the software in a way which made easy sense to them and would give them stability to make changes without breaking stuff. And what one of their guys came up with, and I think it's absolutely genius, is they took the theater mode, which was a mode where you could fly around and you could basically rewatch matches. And they basically created an overlay for that where you could see how many network packets each individual object in the scene was sending and how much latency. And it would all be visualized very clearly. So a developer could fly through and go, holy crap, that grenade rolling down the hill is sending like 1,000 packets a second. That's really bad for our performance. which was really good because they could see how the scene changed and how the gameplay changed in response to the networking fixes that they were making, which to clarify that, that's like they're working on the business logic of like, how does the game feel to play at the same time as working as the latency optimization. And I think that is what stability means. It's the ability to see a broader perspective on your software that you wouldn't previously be able to do. So that's my goal with the stability scan. I think it's going to be really, really cool when it's done. The final thing we're working on is a bulk patching tool. So I've been doing a lot of bug scanning and fixing, and it's absolutely driving me up the wall, solving one defect at a time. So what I'm imagining is a Google Maps-like interface. And when I say Google Maps, I mean more of like the routing algorithm of like a system that looks at the defects, uses our big picture map, and figures out, hey, what's the way that you can solve all of these software defects in the most logical way that also takes the least amount of steps. So it's more token efficient, you're using less LLM credits to do it, but you're also wasting less of your time waiting for an LLM to reply back and then go and test it. And the idea behind this is you would have the LLM aspect of the bulk patching tool, but also the human checklist of you being able to go, yep, we're all good here. And that will hopefully lead to a whole new renaissance in software quality. And that's really the goal of this, is I want software to be much, much higher quality. I want to help people build software that is decades ahead of where we've been for the last couple of years, because software quality has been in a really stagnant state. And LLMs at the moment are helping that, but they're also hurting that. And I think that the advantage that we have and the opportunity that we have is we can actually redefine software quality and reach a whole new level and a whole new level of leverage that we wouldn't have had previously. And I'm so excited about that. I hope you'll join me. I hope you'll subscribe to the channel. And if you want to check out the tool, it's available online now. You just follow the link in the description. We do have a $5 trial. It's not a free trial. And the reason for that is because we are a scrappy young startup. We don't have any funding yet. And we basically just, the large language model in the process is very expensive. If you want to have free credits and you want to go a free trial, please just contact me directly at devin@devinabox.com. I will hook you up with as many credits as you need. I'll walk you through, I'll help you, and we can make it work. So just contact me if you want to give it a go. Thank you so much. I really am looking forward to the future, and I hope to see you again soon.